So let's start with our normal satellite perspective, if we can be. Okay. I'm going to turn off this light. I think some of the stuff that, is that okay? Yeah, some of the stuff that's on the screen will look better. So welcome everybody to our weekly weather discussion. It's usually fairly crowded. It's not usually this crowded. It's great to have alumni, and I'm sorry I missed some of you this morning. I had to run across campus a couple of different assignments, but I hope to see you after the discussion today. So it's been a week of transition, let's put it that way. In a lot of places, not just here. I think we can feel it predominantly in Madison today. Yesterday was warm, and now it's still fairly humid, but a lot cooler, and it feels nicer outside. So, and we're in the midst of just about on the eastern edge of this impressive storm that's getting itself developed over the central plains of the United States. And it has been a really wild week in the northern Rocky Mountain states, all the way down to Denver and probably further south. But it's certainly in Montana, Wyoming, parts of Idaho, and certainly it's been the first visit, maybe the second visit in Colorado, but the first visit at city municipalities outside of the mountainous areas where we've had really substantial snow. So it's been a pretty interesting week. And we can watch, what I intend to do is show you a little bit about the evolution of the weather system that's made its way from the Pacific Northwest to the central United States over really the last 3.5 or so days. And it's, there's a bit of a Lazarus aspect to this thing, because there's a period of time when it kind of died away, and then it's kind of come back with a little bit of vigor, and it's going to characterize homecoming weekend in a substantial way. We may, in the last year, George was just saying, last October 20th, we had a snow squall during the football game. I don't think that's out of the realm of the possible for tomorrow. I'll say that right off the bat, and we'll see whether or not more recent forecast and observational data suggests otherwise. But at least that was true yesterday. It sure seemed like that was a possibility, and we'll see whether or not that's the case. So here's a long-term animation of the infrared satellite image. Pete, you got to tell me how long it goes?
I have no idea what time these images are. I made this loop 10 minutes ago under duress, and I barely cut off the time stamp. So it goes from, so whenever it starts, if we start at the beginning, this starts at 0Z last Friday, and it goes for a week.
Okay.
Every 10 minutes.
Okay.
So you'll have to guess what day it is, unfortunately. Huh?
We just move closer to the end.
No, I cropped it when I made the loop. I
Can we
don't.
just move the length of? So
Yeah, let's get closer to the end. Yeah.
Oh, you want to get closer
Yeah.
to now?
In fact,
You want to just go to today's?
yeah, let's just go to today's.
Okay.
That way we know what we're talking about in terms of time.
Since I didn't do that correctly.
So we'll start with the infrared picture over the continental U.S. today. So this is the last 6 or so hours. I think this is every 10 minutes, right?
Correct.
Yeah, okay. 10-minute data. So really interesting little disturbance south of Cape Cod and the islands off the coast of the middle Atlantic. That has a tropical pedigree. I don't think it's a tropical storm anymore, but it certainly has some really interesting
just named.
eye-like structures. Oh, it was?
Just named this morning, Melissa.
Melissa.
Tropical
I like
storm
that.
Melissa.
Tropical storm Melissa. And it started out as just a disturbance, right? They never gave it a name. Okay, so it's finally acquired a name. We'll take a look at that in the visible in just a minute as well. And you can see here's our storm in the central United States. Lots of low clouds over us. So some of them spitting out a little bit of rain, more of the moderate rain has gone away to the east. But this back here is quite a bit of it in the Dakotas is snow. Not all of it. We'll see when we look at the surface ops. And then you can see that it's, well, maybe you can't see so well on this picture, but there's snow that has fallen over the Rockies in Colorado, the plains of Wyoming, and also the plains of Montana. So there's been snow relatively widespread across the Intermountain West over the last couple of days. And so what I want to show you is some of the evolution of this weather disturbance that's now parked over the central United States. We'll see where that came from and what some of the processes were that drove it to its current location and intensity. And then we'll take a quick look out to the west in a minute. I want to see the visible first, if we can look at the in the black and white visible, please. He likes all the colors. I don't like it. Yeah, so this is there's Tropical Storm Melissa, and with a really tight little center. And interestingly, the eastern side of the storm is the one that's convection free. Very often it's the southwest side in these types of weak ones, but it's the eastern side in this one. And so here's our storm in the central United States. It probably has a name, but that's all commercial. We don't go for that yet. Here's the snowfall in Montana, Wyoming, and Colorado. You can even see it starting to shrink away in the sunlight, even though it's still cold in the northeastern quadrant of Colorado. It was snowing moderately, at least yesterday afternoon in Denver with a 20-degree temperature and 14-degree dew point. You were still there at the time?
Right, I'm still there. They got down to, this morning, 9 degrees in Denver. Wow. 14 at Boulder this morning.
Wow, that's amazing. So that's really quite remarkable. So what a storm it was. So we'll take a look at where it came from. And then widespread, Melissa's the only game in the Atlantic Basin right now. There's a few convective clusters, but I don't think any of those are named or have much of a probability of doing anything else. And then let's take a look, if we could, Pete, at the West Coast. We'll have to look at the infrared, I guess, at this time of day.
If there is a stationary visible, or at least a couple elements of visible that are in a loop, it'd be interesting to watch. Fires have erupted over parts of Southern California.
Oh, yeah.
Last night, or yesterday evening for them, and tonight, I think 0% contained. Yeah, you can see a smoke plume.
Oh, yeah, here's a smoke plume right there. And there's two separate sources, I think, right here and here. And this is a bigger fire, and that's a smaller one. So at least two can be identified right away, even by novices like myself on the satellite movie. So that's pretty impressive.
Closed cell convection. I don't know if you do that.
The what?
Closed cell convection on this side.
Oh, yeah, yeah.
And a couple of things about the fire, and this is for the folks that are taking the hazards class. You probably heard that PG&E, the Pacific Gas and Electric Company, which owns a lot of the infrastructure for electricity generation and transmission in California, they began, based on forecast earlier this week, proposing shutdowns for several days for power, just shutting it down for 5 days. So if you have a house and stuff in your refrigerator, you're out of luck. Because they were concerned about, because they haven't maintained their lines, this is their issue, not, they could have done better. There was, the fire that was, I think, two years ago, or even last year's fire, that was near, what was the name of the town? Paradise, California.
Oh, yeah.
They believe that was triggered perhaps by some sparking from their lines with the strong winds going through the Santa Ana conditions that are developing, with big cold high over the Intermountain West and offshore flow. We'll see that in surface observations. That can generate really strong winds, very dry conditions, and that can lead to fires. And so there's some people out of luck with respect to power because of this event that's ongoing right now. And people were saying, well, the fires haven't started. What's the big issue? Now they've started.
Yeah.
These are probably not necessarily due to the electrical issues, but just wildfires that are spreading rapidly because of the strong winds.
The one down in LA, didn't that start like 10 o'clock last night?
Yeah,
By this morning, it had jumped in interstate and burned a bunch of houses.
Yeah,
This is the shortwave infrared band, and if you look right down in
Oh,
here,
yeah.
these little yellow
See the hot
spots,
yeah.
those are indicative of where it's really hot.
Yeah, very interesting.
So you wanted the water vapor, right?
No, I'll take the whole basin.
Right, and I'll even do grayscale for you.
Excellent. Thank you.
That's infrared, not
That's
water
really
vapor.
nice. So yeah, I want to see the infrared. So here's the infrared, the Pacific Basin, and there's a storm that's kind of made its way up into the southeastern part of Alaska, and it's got a trailing boundary that looks like it's probably sort of a cold frontal type boundary with another weaker development off the coast of Oregon, far off the coast of Oregon. And then not much really well-organized activity anywhere else in the Pacific Basin, at least eastern portion of it. A little bit of a cyclonic disturbance here at about 170 degrees west, but it's not really the kind that you will see later on in the semester when the things really get rolled up and come crashing in to the far Pacific Northwest, not just of the contiguous 48 states. So that's interesting. And I know there's a big typhoon off the coast of Japan. What's the name of that one, Michael?
Hikabis, I think.
Hikabis.
H-I-G-B-A-G-I-S.
And those things are always wild cards in the circulation this time of year. You get a recurving tropical cyclone. If it's already on the coast of Japan, it's well into its tendency to recurve to the mid-latitudes. And that can throw all kinds of different wave activity into a little bit of flux here over the Pacific. It can generate some really interesting weather. So, there it is right there.
So there it is. The concern right now is for parts of southern Japan, the coastal Japan, eastern Japan, as the cyclone was up. It's a category 4 as of this morning. And if we were to overlay the SSTs, you can see it may not loop, I'm not certain, but it's going over increasingly cooler sea surface temperatures, so it's expected to weaken an increasing shear, but a beautiful looking storm
Yeah, thanks.
this morning.
And you can see that it does seem to already have feelers out for the mid-latitude jet, because this is kind of an asymmetric cloud stream. We don't have a perfect view of it. I'd like to have even a further out view, but I think that much of the cloudiness is being raced across the Pacific by the jet a little bit further north. So, yeah, so you can kind of see there's a tendency for that flow to go straight up to the northeast along the Pacific jet. Presumably, that's the direction of the Pacific jet. So category 1, all the way almost past the entire islands of Japan, and so it'll be a factor in the mid-latitude flow for sure. And they vary in how they influence the mid-latitude flow. Sometimes they have a direct, very dramatic impact because they hit the waveguide at the right spot. Other times they hit a flabby part of the waveguide and they don't really do much. So that would require additional analysis. We could do it, but we don't have the time to do it at the moment. So interesting stuff in October. Is a really fun month for the way the interaction between the tropics and the extratropics, especially in the West Pacific. Okay, let's go to our continental view. First, let's look at the radar, so we get a sense of what's happening across the country in terms of current precipitation. And so widespread, of course, along the cold frontal boundary associated with our cyclone, which is sort of in western Minnesota, west central Minnesota. And I believe we'll see when we look at the surface ops that quite a bit of this precipitation in the Dakotas is snowing. And almost all of this is rain. I don't think there's a single exception to that, of course. And then there's a little bit of Melissa just to the south of southern New England, a little bit of precipitation coming in the easterly flow into the far eastern part of Massachusetts, perhaps tied to the circulation of Melissa, but not really bands per se of Melissa, I would say. And then not much active weather in terms of the radar across the western third of the country, for sure. It's all today, anyway, centered in the central United States. And so that is going to give us an opportunity to take a look at some of the obs in this region at the surface first, and then we'll look at upper levels. So let's go to the surface observations if we could. Pete.
John, if we could, 2 other places to look would be eastern New England as well as southwestern part of the United States with the offshore flow, with surface obs.
Oh, yeah, that's right. So, in fact, let's go up to the northeast. We have some pretty strong winds in the Boston, Providence, Hartford area. So 20 knots out of the straight north-northeast at Boston, 25 at Provincetown, 30 at Nantucket. So very strong winds. Remember, Melissa's right about here. It's a pretty decent circulation. And places right in southeastern New England are feeling it better in terms of the surface off than anybody else. It's too bad we don't have a few buoy observations out here. I think they're all kind of out in this part of the North Atlantic. It'd be nice to see a couple there. Might have some strong winds, but 30 knots at Nantucket is pretty good. 57 over 55, so it's a relatively warm, tropical feeling day, fairly high dew point for October, and 30 knot winds, so pretty strong. We have kind of widely scattered rain across the state of Wisconsin. Madison's not raining, of course, it's 44 over 38. That's the lowest dew point we've had in a very long time. Heavy rain up at Oshkosh, and then moderate rain in Milwaukee, or maybe it's Kenosha, but I think it's Milwaukee. And so same temperatures just about everywhere, 52 over about 48. So a little bit warmer and more moist to the east. The boundary here in terms of the storm, I was trying to find the cyclone center. So even north of Ironwood, heavy rain. So it's kind of some widespread moderate to heavy rain. The center of the circulation is
Northwestern Minnesota.
Yeah, back up in this region. So here, this looks like it's right about in here, right? And so the lowest pressure that I can see is
996.8.
That's not right.
Yeah, there's 996.8.
Yeah, this would be 962.7. Right. So somebody's kind of vaping, and they shouldn't be on the job, I guess. 996.8. Yeah, so about 996 right over the far northwest corner of Minnesota. Look at the heavy snow in parts of North Dakota, though. Moderate and heavy in some locations. There was earlier some moderate snow in northeastern South Dakota as well, and then there's snow throughout parts of central Minnesota. So
we have low visibility, strong winds, falling snow. So that's why they have blizzard warnings up for those.
Yeah, that's right. And but there was a really dramatic boundary this morning between the warm, moist air and the colder, drier air, and you can kind of see some of it back down here over Tennessee and Kentucky. So, for instance, down near Memphis, you've got a 62 over 61, but a northwesterly flow, and just to its west, 49 over 43 in northern Arkansas, 55 at Little Rock. And then just to its east, you've got dew points in the high 60s, mid 60s, and temperatures 70 to 80. So that's about where the boundary is in this location. And then one could continue trying to find it further and further along and probably differentiate mostly by dew points. It's down here in eastern Illinois And so it's right in like this, pretty much along the Mississippi up till the Boot Heel of Missouri, and then straight up the coast. I think it probably is across the center mile of Lake Michigan too, but 64 and southeasterly on the eastern side and 52 and 48 at Milwaukee. So it's a pretty obvious front, even in the surface off, and we'll see it's pretty obvious at the upper levels as well. And then let's take a look also, as Michael pointed out, it's a good idea. Let's take a look at the offshore flow in Southern California. Howling 25 knot wind. I don't know the stations here well enough, I'm sorry, but it's just around at the Bight. This is probably a mountain station, so strong winds, howling. Look at it, 54 over -2. So that's really dry air that's getting into that fire region. That is not a good idea if you want to keep them under control. 80 over 14, is that Los Angeles? I don't know exactly where these places are, but 80 over 14, 77 over 27 at San Diego, 61 over 4. These are sort of Hall of Fame type odds. I like this one here, 52 over -6. That's awesome. You know, people at 100 always say, can the dew point be below 0? Oh yeah, it can be below 0. Yeah, it can. So the biggest dew point depression at a glance is right there, 59. That's pretty incredible. But it's a dry heat. Yeah.
Let's go 70.
What?
76.
Where's the 76? There's 69.
No,
Yeah.
to the east of that one.
Oh, 76. Yeah. Okay, that's right. 76. That's Phoenix, isn't it?
I think so, yeah.
Yeah, Phoenix. That's a dry heat.
Yeah.
Oh boy, is that miserable. Okay. You know, you can't leave the swimming pool without your towel being right next to you in conditions like this, because you'll have hypothermia.
You'll freeze,
The
yeah.
water just evaporates right off your skin. It
It
jumps
just turns to ice, right?
Yeah, it probably does.
It probably does.
So some pretty wild stuff going on down there. Yesterday in class, we were looking at the Oklahoma Mesonet, which is a fantastic resource. Today, it's all, the cold and dry air has made it all the way through the state. So today's current off wouldn't really be any good, but yesterday they were great. We were seeing 15-degree temperature drops in 10 minutes in some of those stations like Okmulgee and, you know, some of these funny names in the small towns. It's a great thing to look at. I don't know if Dan's here. Dan's not here. Is he, Dan Hottown? No. But Dan Hottown and I were looking at that many years ago one day when he was a senior undergrad, and it turned into a master's thesis project for him. He got a really nice paper out of it. So you can find these things just by playing around with looking around through the data, which is really fun. One of the great things about our science. Okay, let's take a look at some of the upper level charts. Let's start at 300 millibars.
I did get a report from somebody watching the stream that there was reported snow in La Crosse this morning. So
Oh, is that right?
getting close. Yeah.
Okay.
Apparently they reported on Twitter. Really send it out. So we're going upper level.
Yeah, and
I hope these work. I didn't usually test them before Weather Watch. I didn't have time today. So we're going 300.
300 first, if we could. So these we call the super Petes. For those who don't attend every week, we call them super Pete because Pete makes them. Yeah, he's super, but they're also gigantic. They cover a lot. These are our super. Very different story today than Tuesday. We had, and I'll show you some of that. Tuesday we had this upper trough, sort of just elongated and positively tilted, coming off the coast of British Columbia. And gradually, as it's made its way across the high northern Rockies, it's begun to cut off, and so it has this slight negative tilt, number one, and ridginess downstream as a consequence of that tilt. And that's really helped to reinvigorate the developmental potential of this upper disturbance, in my opinion. So you have a maximum in cyclonic curvature here in a local, but not as intensely, minimum in anticyclonic curvature there. So right in between the two is where the maximum curvature-induced upper divergence is going to be. That happens to also be in the right exit region, the left exit region of this stubby little jet core. So right over western and northwestern Minnesota at 12Z, one might suspect the most impressive upper developmental processes going on with respect to both the jet and the upper trough. So that's interesting in and of itself. What does it look like at 500 millibars in the same region? Let's take a look at that. So at 500, you've got a really intense baroclinic zone on the southern and eastern side of this disturbance. It's minus 17 in Minneapolis, minus 28 in at Mount Rapid City, Sioux Falls. And so you got a really sharp upper tropospheric temperature contrast here. This is an upper front. I'll show you this in Vis 5D in just a minute. And so downstream of where this front ends, where presumably you have the greatest vorticity both from shear and curvature, that's where you're going to have the greatest PVA by the thermal wind. Again, west central Minnesota. So everything's going on right in that location at this time. So let's see what it looks like at 850. That's where we're going to have our geopotential height minimums, my guess. Yeah, just about. So it's a little bit further to the north. Here's where you see the really intense lower tropospheric baroclinicity associated with this storm in its current state. So this is really strong, 15-degree temperature contrast over a very short distance on the cold front, and it's just making its way into the state this morning at 7 a.m. at 8:50. So it certainly was past us at the surface just an hour or so after that. And then here's the baroclinicity associated with the warm front that's been ingested into this development from the prior disturbance up over Hudson Bay. That was a trailing cold front, and it's taken the frayed nature of the baroclinic zone as the storm decays to the north and really incorporated it into the warm frontal structure of this new storm. And you can see that the gradient is stronger the closer you get to the center of the cyclone, because the deformation is stronger closer here than it is over here.
John,
Yeah.
where you were looking at effectively the forcing for vertical motion, and you're placing the low a little bit further south than where it's analyzed there.
Yeah.
I'm wondering, is that just an indication that the height falls are probably still south of where the main geopotential minimum is there, and so it's
It might
slowly
be.
moving, so the cyclone is probably stuck.
Yeah, it might be. And it also indicates to me that the direction of the shear in the lower troposphere is a little bit more southeasterly than I thought. I thought maybe it was a little bit more southerly. And so that's going to tend to force the thing a little bit further to the west, and northwest also, because the vertical shear direction is sort of the direction of the 850 millibar isotherms, better represented by the 500 to 1,000 millibar thickness lines. So yeah, it's a complicated change in the vertical structure of this thing right near the cyclone center. Okay, if we could, Pete, let's just take a look before I go to this 5D, and then I'll be done. Let's go to the movie of the 500 millibar analyses, and when we get to Tuesday, we'll stop there and we'll kind of page through.
By the way, Dan Hartung is watching online. He says hi.
Oh, he is. Oh, good for him. Yeah. So did he get a comment about the Mesonet?
I think he probably did hear the comment about the Mesonet. He said, "Hi, John. I'm there in spirit, but watching it in real time,"
All right, very good.
with a smiley face.
Okay, so Tuesday was the 11th. I know, what day was Tuesday? Was the 8th? Yeah, the 8th.
We got one bad frame in there, but
Okay, right here is great. Let's go one more, right there, 12Z. So 12Z on the 8th, this is the position of that upper trough that is now occupying the central United States a few days downstream. Look at how intense this upper front is. I'll show you this in just a minute in Vis 5D. It's minus 35 at Nanaimo on the British Columbia coast. It's minus 20 at Quileute. So there's 14 degrees temperature contrast in there. And then notice this isotherm comes in and has a little kink in it, and then it goes back down again. So this region is where the strong subsidence has historically been. It's extraordinary temperature contrast. Minus 15 at Corvallis and minus 30 back up here, in Bellingham. So that's a really strong upper front. Almost always it has really strong vorticity with it. There's a 95 knot wind at Quileute. There's only 25 knots at Nanaimo. So there's strong horizontal shear and there's decent curvature as well. That's an impressive upper feature. Then there's a secondary feature along the chain of lakes in the Yukon territory that's also going to develop as we go forward in time. So let's just click through the next time.
Oh, before we
Yeah.
So when you're talking about that isotherm that kind of comes in and
Yeah.
into the subsidence,
This one here.
it's amazing. If this were 20 years ago, when we're doing this weather watch, then we wouldn't see any evidence of that in the analysis.
No, that's right. This one would be straight down like that. And so you'd say, okay, most of the baroclinicity's in here. And the analysis knows something about
the processes that are going
about
on.
the structure and the processes that produce the structure. That's really neat, right? Yeah. And when you're doing your own analysis, anybody who does hand analysis, if you know about subsidence going on in this portion of the upper front, you should kink your isotrope like that too, because that's what's really happening. And I'll just point one last thing out. There is slight cold advection in this cyclonic shear region, so that forces subsidence as well. There's a good dynamic reading for that. Yeah, great.
Yeah, I think an interesting thing here is let's talk a little bit about why they're getting such strong downslope in California after this. And it's not obvious looking at 500 millibars, that should be the case. Often when there's a Santa Ana wind, you're getting a kind of a ridge leaning over from the west. There's something slightly there in Southern California, but not much.
Be careful, this is
Tuesday. This is not.
Oh, this is a couple days ago.
Yeah, because you're right. What happens with this development is, in my opinion anyway, the development is asymmetric. The anticyclone really develops with the passage of this wave. The surface cyclone struggles to find its footing
That's
over the
what it
mountains. Yeah,
Mhm.
yeah. So the anticyclone gets in place for the Santa Ana from this exact same disturbance. Okay, let's go forward time, see what happens. What happened there? Okay, so this is the next day. So you can see a kind of a separation going on between the northern disturbance, which has its own little ridginess downstream, a decent baroclinic zone, and the upper front disturbance, which is now over the Columbia River Basin, right there on the Oregon-Washington border. Still very cold. These are all minus 30 or colder, and you could see it in the open cellular convection on Tuesday off the British Columbia coast. They were widely spaced, and I think we did it in class and made the guess because I spent some years in Washington. And when you can almost make a guess based on the 500 millibar temperature, how far the spacing is between cells. And I said, I think it's about minus 30 or 31. It was minus 32. I felt good about that. I can't forecast anything else except these obscure, ridiculous things that no one pays attention to. All right, let's go forward another time. And you'll just see the gradual separation between the northern and southern disturbance. So this thing is starting to kind of find its way southward through southwestern Idaho. It's still a pretty intense curvature maximum. Notice there's no downstream ridging at all in the flow that goes up to the north and east. Keep going, Pete.
I think I got a bad frame in here somewhere.
Oh, that's okay. All right, that was it.
It was
So
close,
this is the
yeah.
whole day?
Yep.
Okay, so here's a little bit of a weakening of the intensity of this upper trough, right? It's not quite as intense as it was before, but there's beginning to be a ridge just north of the Canadian border. And the northern disturbances over the archipelago are doing a pretty good job of keeping the baroclinicity concentrated even at 500 millibars associated with it. And then here's really strong northerly, northwesterly flow. Anticyclogenesis is going on like crazy over parts of Nevada and Utah, and that's setting up the Santa Ana. This is now yesterday morning. So one more time. And then it's really starting to cut off. Is 1 year potential height line that's just about cut off, and that is of course a function of ridginess downstream. And so again, Santa Ana subsidence over Utah and
The Santa
eastern
Ana
Nevada.
subsidence would be over California.
Well, I mean for the anticyclogenesis. And then the Santa Ana is offshore flow responding to the pressure gradient.
Yes, but normally you see some slight easterly component of wind aloft.
At 500.
Not at 500 millibars.
Yeah, you do a lot of times, but at least at 700.
Still early, you're still early.
So you mean if your ridge really breaks like that?
Yeah,
Yeah,
right.
okay, yeah. I don't know if it does.
Let's go a couple more.
Let's go a couple more, yeah.
A little early.
So here we are on this morning, right? October 11th today?
Yeah.
Yeah, so this is this morning. And it's really, I think what's going on for the production of the offshore flow in California is not the dramatic wave break over the West Coast. It's instead just the anticyclogenesis in the interior. That's probably driving that. And you'll see that reflected in the sea level pressure forecasts.
I don't think so. You have to have at least at 700 millibars. There should be some easterly component.
Okay, we'll check that out.
Or northerly component where California's.
So before I show you the Vis 5D and we go there, you can see the ridginess downstream, and you can see again, all of a sudden the baroclinicity starts to get resurrected on the southern side of this trough axis. And the geopotential height gradient gets stronger too. These are all uniformly 90 knot winds at 500 millibars. So it's pretty strong flow in the middle troposphere, and it's intensely baroclinic. And for a while, the baroclinicity disappeared. So this thing's undergone a little bit of an evolution over this time. So let's at this time then, let's take a look at the 700 millibar chart.
Well, that's coming up, John. What's your speculation as to why that baroclinicity has increased? Is it a response to the cyclogenesis, the surface cyclogenesis?
It's a good question. I don't know. I'm going to show you in Vis 5D that what you see is the PV the tropopause gets pressed downward again. It's like a second tropopause fold. I don't really know why that happens. And it's a good science question, but it seems to be part of the story here. So here you see an easterly wind in northern Arizona, but there's not really any easterly flow even at a
Can you go
couple
back
miles
a
above sea
frame?
level.
Back 12 hours earlier than this.
I think that ridge is just beginning to build.
Yeah, I think so too. And it's interior. It's not on the coast. It's not quite as on the coast as it sometimes is. So that's 12 hours prior. So there's easterly flow at that station.
Yeah, there's a little bit there. And then
Yeah,
northern-
and further north in San Francisco.
Yeah. It's a little bit. It's not impressive easterly flow.
Yeah.
I think the fact that the models were able to pick this Santa Ana effect up is pretty good. I don't think a forecaster necessarily would have
Yeah.
picked it up based on this. It's just, a downslope windstorm is flow going over the barrier down the other side, and this just is not dramatic like you see in many cases.
Yeah, well, what is dramatic, and maybe this is something that is a factor here, I don't know. What is dramatic is the anticyclogenesis in the interior,
Yeah.
in Nevada and Utah. That is really dramatic.
One of the things I saw that was dramatic is at 700 millibars. It's extremely dry in Nevada. It dry as you'll ever see it.
Yeah,
And,
yeah.
that could be part of the situation.
Well, all along the coast, you've got a trio of dew point depressions in the mid to high 30s, which is just remarkable at 700 millibars. That's bone dry, and it's It's not equal to anywhere else in the interior, so that is a function of coming over the Sierra and drying out at this level. Okay, I want to just show you a couple things in Biz 5D. I can't spend too much more time on that, but if we could go to that, Pete.
I gotta say real quick,
Yeah.
Melissa Breeden is watching, and she says, shout out to Subtropical Storm Mead.
Oh, yeah.
So, hi, Melissa.
Yeah.
So we're going Biz 5D, right?
Subtropical storm B, yeah. Millibar, temperatures every 2 degrees. Let's look at the vertical cross-section that I prepared for this, just so you can see that. And just
Vertical
take theta, yeah, and then tilt it up. So there's the upper front, and swirl it around a little bit, and yeah, no, the other way here. Okay, so there's the upper front. That's a really nice upper front associated with this barocclinic zone. And what about the PV, PZ? So this is the PV every 1 unit. So there's 1, 2, and so on. And so there's a nice pendant of PV that comes down along that upper front, and then the jet. Just so we put the speed on there and see what the wind speed looks like. That's 20, 30, 40, 50 knot jet right in that location. So everything's kind of nicely lined up. A beautiful structure here of a steeply sloped tropopause, then a fold along the upper front, and the jet core right there and around. It's kind of about 300 millibars or so at this point. So very nice picture of the way that the atmosphere is structured in the initial time. So let's now, in the interest of time, go back to the top, take these things off, and we'll just do the isosurface of PV, which is the 2 PVU surface. I've colored it by pressure. And maybe we'll bring the map up so we can see it underneath. Okay, so you kind of know where you are. So here's the upper level trough that we just cut through like that in the cross section. We can see the nice upper structure associated with it. And then let's put sea level pressure on top of this. Hope you can see those blue contours. I've got only lines that are 1,012. That's perfect, Pete. Thanks. 1,012 millibars or lower. So we're looking just at cyclonic disturbances here. And so we're going to march through the forecast. And just at this initial time, here's an upper PV feature, of course. And then immediately down sheer of it, there's this little bit of an appendage of relatively low pressure from this elongated pressure trough over Alberta and Manitoba. And so this is the development that's associated with this upper trough at sea level. So let's step forward a couple of times. And you can see that here comes the upper trough as we saw, and this is the northern trough, and a separate one. They get more and more separated, even in the PV view. We can keep going. There is this tendency for a little bit of low pressure center there. Here's where the development really starts to take off, but it's over the Intermountain West, so part of it might be fueled by subsidence over the mountains and so on. It's hard to divorce it from the dynamic part. Very much more separated by Wednesday 6Z, northern and southern disturbances. This one's over Oregon. Still has this little pressure trough that sticks out associated with it. But you can notice that the development is not that intense. Can we keep going? The development to the north is much more intense. We're down below 1,000 millibars. And we see this little appendage paying attention to that upper PV feature as it crosses now over the high terrain near Salt Lake City. It's going to start to look a little less impressive. The coloring goes down to a lighter yellow so that it's not quite as deep as it was. We've probably got a nice lee side contribution to some of the troughiness in the immediate lee, this inverted trough. But there's still this little patch of slightly lower than pressures, than a little bit of a trough there, and it's downstream of this upper feature. Let's keep going. Then watch what happens. Here comes the ridginess in between the northern and southern disturbance, right there north of the border. And it looks like the fold starts to deepen again. So keep going. Here it comes, getting more orange. There's just a pressure trough that stretched across. This is now this morning, almost this morning. Now, yeah, we're at midnight last night. Look at how this upper trough feature has gotten more dramatically deep. The tropopause undulation is steeper, and down sheer of it, that's where development starts. Watch. Look at that. Isn't that amazing? Comes over the Rockies and turns into this really potent upper disturbance. Down sheer of it, PVA by the thermal winds driving the cyclogenesis. Keep on going. And this gets us to, now we're into forecast. This is right about right now. So we're getting into forecast mode. But there's your really dramatic upper PV feature. We'll cut a cross section through it in a minute. But it's down sheer of that feature that you have your development in Minnesota. So I don't know how this thing re-energized itself.
So I'm wondering,
That's what's interesting.
Yeah, as the surface cyclone develops, its circulation is then going to have an imprint on the base of that upper trough. It's already low, right? And so the advections there, this is like the Wandishan and Nielsen-Gammon idea. They did the PV inversion
Yeah.
in different levels and looked at how the mutual circulation interacted. So I'm wondering if that's possibly what's happening there.
I don't know, one way to get at that might be to just actually examine this in real detail. What happens to the PV isotels at various levels or on one data surface? Are they being compacted by some sort of a genetic activity that's driven by circulations that are remote to that level? That's possible. But this is a weak disturbance. That's the thing that gets me, that I think there's something internal going on here that's maybe it's just that the baroclinicity has aligned itself along the wind speed maxima in such a way somehow to start to induce subsidence again in deep in this upper trough. Whatever it is, this thing becomes a fairly potent cyclogenetic disturbance. Finally, took forever to do so, and it's really starting to do that now, right at homecoming weekend, and it's going to keep on going. So this is right now. So let's keep going, Pete. So this gets more and more intense. This is maybe about the maximum intensity tonight, because right about here you got the almost vertical superposition of the minimum sea level pressure and the upper PV maxima or vorticity maxima. So there's not going to be too much more PVA or by the thermal wind anymore. I don't think we're going to go below 1012, 8, 4, 6, 992, so 990-ish millibars. And let's see if that's true. Yeah, it expands a little bit, but that's it. So we're done at about 990 millibars.
If we could go back to maybe just before our time, these were every 3 hours.
Yeah, I think they're every 3, yeah.
So we're talking about the position of the surface cyclone, and you were showing earlier, we looked at upper level maps, 300, 500 millibars, looking at the changes in curvature and the implied divergence from
Yeah.
And we were suggesting perhaps it's not going to move much, and you can actually see that's pretty much the case.
Yeah, that's
If
right.
we advance forward,
Yeah, it stays in
there.
northern Minnesota. Yeah, it doesn't go anywhere. The pressure gradient gets changed all around it.
Right.
We're going to be really windy tomorrow, tonight, but it's gets to about 990 and that's it. But it's really interesting to me how that upper disturbance, from this perspective only, and that's all I'll say, re-energizes itself upon getting across the Rockies with a weak disturbance at the surface. So if there's interaction, it's really remarkable that it has that much influence. If there isn't, there's another question about what forces this thing to redevelop as an upper disturbance, because it really does come back to life.
this might be a good case to look at for the project.
Yeah, it could be. Yeah, it could be.
I would throw out there, with the climate conspiracy theory world, I would consider how much available moisture is still sitting on the ground in the Midwest. I mean, I don't know. I mean, everything's flooded, everything's wet. Is that changing your temperature gradient, your moisture gradient in some way near the surface that's impacting the way that?
Well,
I don't know.
certainly, Chris, there's going to be an enhanced latent heat flux for sure. I mean, with a lot of water on the ground. That's what I'm thinking is going to happen tomorrow with our snow. If we have a chance of it, it's going to be because of that. If it gets wet today and doesn't dry up, it's going to be available. So the same kind of thing is what I'm thinking about for tomorrow. And I don't know about what it does for development, but it's a factor for sure. So that's what I have. We could do more with Vis 5D, but we don't want to do that. There's other things to talk about. But this is the kind of thing we can look at. Every single Friday, we have a blast doing this, especially when the weather gets interesting, i.e. we move out of the tropics. And that's when it's really fun for me. So anyway. Okay, so I guess Michael's got some things to talk about next. Thank you, Pete, for driving so expertly as usual.
So we'll start off with, let's go to the Pickle weather site, and this is just showing sort of the watches and warnings that are currently going on. As John was mentioning, we looked at the observations. We saw, the heavy snow, strong winds, relatively low temperatures. That's not a factor, but reduced visibility with the falling or blowing snow. That's going to rise to blizzard warnings for parts of North Dakota, and winter storm warnings and winter weather advisories. The blue that you see shaded here, and their scale here is this is just a free warning. I'll make sure I'm getting that right. For the Weather Service is posted for a good portion of the upper Midwest into the Central Plains. So this is, so the coldest era of the season, vegetation, fragile not vegetation, but certainly end the growing season for some of those plants. That's it. And so coastal flood advisories out over the eastern part of the Atlantic due to Melissa being offshore. I thought Melissa was actually still in Germany.
She's in Germany still, yeah.
Right, so maybe she can explain that in her next text. Anyway, and then finally, in the far western part of the United States, we see this red flag warning. Chris Malcolm was talking about that in the over parts of Nevada when he was here a few weeks ago. But we have these strong winds and very low dew points, so the potential for some fires to get started out in these regions. So something to, that they're concerned with at the present time. So what I'd like to do next is take a look at some of these tropical cyclones. We'll start first with Melissa. So we'll go to the NHC page, that tab that's in the.
She's currently texting me something, so I'll share that in a moment. Where are we going?
Subtropical storm Melissa. Only subtropical
She's
storm.
back now. She's enjoying the snow in the mountains that we have here.
Okay, so Melissa's just a wimpy storm off the east coast of the United States.
Nondescript.
Yeah, nondescript. John said that, not me. We can look at the stats for this. We can look for the stats for this in just a moment. Scroll down. We'll look at let's look at the discussion very briefly, and just scroll down. Let's get some of the latest stats. So as of 15Z today, 55 knot winds, 65 mile per hour winds, and the structure of the storm is really interesting. We'll take a quick look at this in terms of the so-called phase space diagram that folks, I think Bob Hart at Florida State has this diagram to identify what's the structure of the storm based on certain wind shear characteristics over different layers in the atmosphere and how they line up. So if you go there, A is just a few days ago. That's the start of this, when again, it's 54 hours ago. C, this position C, is the current condition. This is as of 6C this morning. This is based on the GFS analysis. And this is kind of an interesting diagram. It looks at the lower tropospheric shear, thermal wind shear from 900 to 600 hectopascal, and then another one that's, let's just scroll down a little bit. I don't want to look at this. This is storm relative. Or let's look at these right here. This is 900 to 600, and then this is 600 to 300 hectopascals. This gives you an idea based on where these thicknesses line up over the storm. What type of storm is it? Is it a classic extratropical cyclone? Is it a deep cold core disturbance, which has its origins or its dynamical forcing in the upper troposphere? Is it a deep warm core cyclone like a classic tropical cyclone? Something relatively shallow. So this phase space kind of is a very useful way to indicate, and the Hurricane Center uses this to some extent to determine, is this a tropical cyclone or subtropical cyclone? These are some of the indicators that they use. So currently it's considered a shallow warm core disturbance located out over the Atlantic, and its evolution over time in this phase space is for it to gradually migrate to the, if you will, the southeastern portion of this phase diagram, become a deep cold core disturbance, so becoming fully extratropical and have its dynamical rootings in the upper troposphere. If you look at the location of the tropical cyclone relative to the sea surface temperatures, remember 26 degrees Celsius is kind of a critical temperature for tropical cyclogenesis. This goes back to historically work people did looking at tropical cyclogenesis and development. And this developed just right on the edge of the northern wall of the Gulf Stream. So this is not a full, classically tropical cyclone in terms of its origins, and it's not over conditions that are fully favorable for it to become fairly intense. The things that are going for it right now, I don't know if you noticed with the Vis 5D when John was showing the potential vorticity and the sea level pressure, it's right under an upper trough right now. So that's, it makes the shear pretty much zero over it. So that's a favorable thing for the storm. But as it begins to move, the shear is going to be an increase, and it's going to undergo a transition, becoming more extratropical over time. This is based again on the 6C GFS forecast. But there are kind of neat ways of looking at tropical cyclones. I think this phase diagram, we can talk about it more on a later weather watch. It's kind of an interesting tool to assess the certain characteristics of tropical cyclones. So go back to the this tab from the Hurricane Center. As you can see, it's kind of at this point, they believe it's at its maximum intensity, and it's expected to weaken, becoming post-tropical as it undergoes a transition. The phase diagram says nothing about the intensity of the storm, just what are the characteristics of it in terms of how it might be classified.
Yeah, just remind you how sensitive these tropical storms are. Oh, I need the right sea surface temperature. Oh, I need the right shear. Give me a break.
Yeah, and extratropical cyclones, oh, I need the right paraconicity. Oh, I need an upper trough. Give me a break. Let's go to the Western Pacific, Sims tropical cyclone. So we looked at Melissa, again, kind of wimpy. Trying to get those digs in there. And then you can see the forecast track. Let's look over the Pacific. We already looked at this once, just get one more look at it. We'll go to the 8-kilometer imagery right here so you can get a sense of the extent of this. Again, this was also a really interesting storm that intensified very rapidly. I don't remember seeing 90 mile per hour intensification over a relative 12-hour time period, something earlier in the week. This thing on Monday morning, Monday afternoon, it really rapidly intensified. Underwent an eyewall replacement cycle, sort of fell apart, came back together. It's a fairly intense storm, and you can see where it's located. You can see also this broad plume of high cirrus that extends away from the storm. This is in part characterizing some of the outflow. Even beyond this, there's outflow. We're going to look at this along the dynamical tropopause. And we'll go to the coastal weather site and get a broad picture of how the cyclone actually is going to impact the mid-latitude westerlies. What's really interesting about this, as John was saying, is that this time of year, through November, these transitioning tropical cyclones, as they move into the westerlies in the western part of the Pacific Basin, have a big impact on weather over North America in terms of the long wave pattern, getting us, our first big, deep cold waves, or broad, expansive ridge over the eastern part of the United States, keeping us relatively mild. And just how it impacts the westerlies is going to have a big impact on what the downstream response is over North America. But I think it's just interesting to see that perspective. So we can close this out, go to Pivotal Weather, we'll go to the GFF, go to their model page, and go to their models. We'll go to Dynamics, and we'll come back to local forecast in just a minute. So look at this, the PD theta, and we'll go to the zoom. We're going to go continental, and we'll go over to the Pacific. It's one of the most conspicuous things that you can see on this map, I think, or the most interesting things, is this broad area of very warm temperatures along the dynamical tropopause. So Professor Martin, John was just showing in Viz 5D this isosurface of potential vorticity. So here we're looking at this isosurface effectively flattened and then colored by the potential temperature along that surface. So these warmer colors are a much higher elevated tropopause. The tropical cyclone is located right in this location here. And some of this is in fact the outflow from that tropical cyclone. It expands beyond just the cirrus, it goes a bit further out. And where we see the strong gradient potential temperature along this tropopause, that's where the tropopause is relatively steep. We saw those nice cross sections earlier. That's where we have the strongest winds. So the jet is right along the jet core, right along the edge of this boundary, where we see these strong thermal gradients. Okay, so the tropical cyclone is pretty far removed from the jet, and in fact, it's the outflow from that tropical cyclone impacting the lower tropopause further to the north that helps define this jet. As we go forward in time, we can just sort of see how this begins to help churn up what's going on in the Pacific. I'm not going to make any conclusions upon its impact, but you can just sort of follow along the ridge development over the Western Pacific and this downstream trough that begins to intensify. We can go in bigger steps. Oh yeah, look at that. Yeah. So this outflow, these northerly winds helping to drive and help intensify this trough over the central part of the basin, which in turn is going to help to pump up a ridge further to the east of it. And then you can see sort of just so-called emerging downstream impact. But the tropical cyclone here is not, it looks like it's going to go right across the southern part. I lost track of my island, these are the names of these islands, but it's going to move just east of Tokyo. Let's go to 36 hours, please. So this, you can see this narrowing upper trough, this pendant of potential vorticity that's gotten sort of pinched off. But again, this is pretty well documented in the forecast. If we were to look, just as an example, say, well, okay, this is one forecast. Let's look at, is there any uncertainty in this forecast? Let's go back from the model runs. Let's go back a day and just see how much this forecast has changed. Wow, that's pretty good, isn't it? Yeah, not too different. We go back a little bit further. Well, we can do that. Wow. So this interaction appears, again, from a very limited set of model runs that we've looked at, to be right on the mark. There's not much uncertainty in the forecast, at least as expressed in the differences in forecasts initialized at different times as this tropical cyclone has moved into the westlands. Right. So I think that's kind of interesting. But this is, again, these are nice maps to look at when you want to look at those sorts of interactions, and we'll just follow how that eventually evolves. But let's come closer to home. As John knows, my favorite time of the year is when we get our first snowfall. I love snow. Actually, I don't really, but we'll go to the yes. Thank you. And let's go zoom in back over to continental North America. Go to national. All right, and then click on that regional. And I want to switch models to the NAM, partly because it's a bit more interesting. But for those of you that are on original forecast, let's go back to 6 hours before today. Yes. So a couple things that are of interest. There's Melissa offshore. Here is that forecasted heavy snow. You can see in the forecast, this is valid at 18D today. You can see the front shows up really nicely in this. Remember, we saw the heavy rain in Green Bay earlier. This is the sort of reflectivity from the model as this weather system pushes to the east. Really well-developed cyclone. I would admit this is a nice-looking cyclone.
See?
But even as nice as it looks, it's pretty much the same intensity as the cyclone offshore.
Look at the real estate that's being precipitated on by that thing compared to your little, sorry, Melissa.
So here's this forecast precipitation type heavy snow. You can see from the pressure gradient here, the implied strong geostrophic winds here. That's kind of capturing the elements for that the blizzard conditions that are occurring over North Dakota. If we step ahead, let's go to 18 hours before. They're consistent with some of the things that John was showing earlier, the divergence aloft. And you have this nice precipitation shield around the cyclone, along the front. Presumably this is all frontogenetically derived, and some in this raw warm sector and trowel-like structure that extends from Ontario all the way back around the cyclone into the where we're having those blizzard conditions this morning. Key thing is, a couple things to note for the quality of the forecast or what the weather's going to be like over the weekend. Let's go ahead to 24 hours in the forecast. We have this broad cyclonic circulation. It's becoming sort of vertically stacked, as we saw from the vorticity analysis. We'll look at moisture as well in terms of relative humidities. But this broad cyclonic circulation over a frictional boundary, so we know Ekman pumping is probably going to be at work. There's probably going to be a very large cloud shield over us. So tomorrow's probably going to be mostly cloudy. There may be a few breaks early in the day, but this is going to be kind of a stratiformy type day. I think that's going to begin emerging particularly during the afternoon. Model at this point is not showing much in the way of precipitation. Most of it's still focused back to the northwest of the cyclone center and just south of the cyclone center. And we'll look at a couple different levels as well, because we'll see in the forecast there is, we'll go to 500 millibars now, I guess, 500 millibar heights and vorticity under dynamics. Okay, we have the broad cyclonic circulation. Also, this is kind of neat. The strip of vorticity breaks up into little disturbances. I guess it's barotropically unstable. That'll be interesting to watch. But we have these bands of vorticity that are around the cyclone center, and they're forecasted to begin moving, or continue to move around the cyclone, passing over us during the course of the day tomorrow. Go to 30 hours, so 18D tomorrow. Okay. To the extent that we believe the forecast, these little bits are beginning to roll up. We got a nice local maxima in vorticity. It doesn't have much of an imprint on the height field. You can see there's a slight trough right here, but there's this vorticity maxima, and it's headed kind of right toward us or just toward north. Go ahead, 3 hours, please. To 21D tomorrow. This is mid-afternoon tomorrow. What time is the game early? Is that 11? 2:30. Okay, so during the afternoon tomorrow. Again, broadly gloomy. Not the game in terms of the results. That'll be certainly fantastic. But I really can't forecast that. But
Spotty will fall.
What's that?
Spotty will fall along with
Okay.
snow or rain.
Definitely. So as this disturbance begins to move by, downstream of it, we have positive vorticity advection. The isotropes are going to be steepening. As John mentioned, the surface is relatively moist. If we get any heating, if any bit of sun, I think that's kind of one of the limiting factors. Let's get some instability occurring. Lapse rates as they steepen, get some convective showers occurring, and we'll see if the temperature profile, we're going to be cool enough for perhaps some frozen precipitation as this weak disturbance passes by us. If we go to vertical motions, vertical velocity, let's go to 850 millibars at this time. See, there's a band of ascent that's occurring that's just downstream of this very weak upper vorticity, or isolated but weak up vorticity feature. Let's go ahead another 3 hours. I think the models are forecasting sort of in the late afternoon, early evening. When we get it. So this really intensifies and congeals as it passes down the valley to our southeast. Big burst of vertical motion. Let's go back to the surface precipitation. Let's go to 24 hours and look at the evolution of the surface map. So let's go that one. Go back to 24 hours tomorrow morning. Okay, and we step ahead 3 hours, 27 hours. Still mid-morning. Again, not much over us at this time. The vorticity strip is beginning to evolve. Go ahead again. You can see first snow showers beginning to develop. You can even see a weak trough-like feature that begins to develop just around a cross or so to our northwest. And we go ahead to 33 hours. There comes rain showers initially, and I guess the column cools just enough as this feature goes by for it to transition to snow. 36 hours.
This is just like last year.
And so a mix of rain and snow. Again, thicknesses are, I guess, somewhat marginal, but let's do a vertical profile. Let's just click on this and look at the sounding over Madison, close to Madison. And yeah, this is perfect for frozen precipitation.
Yeah.
A surface temperature, just about what, 35, 36. Here's the 0 degree isotherm. We're well below zero, the whole column. So this will be frozen precipitation if it occurs. How much? We can go to the total. Let's go to the winter weather item right here, and let's look at the 6 hour 10-to-1 ratio for precipitation. This is as of 0 Z, so it's just to our northwest. Let's go ahead 3 more hours to 39 hours in the forecast. So this is actually begins to
That's that little disturbance that you used.
Yeah.
One or two.
the timing of it's going to be a little bit. Is going to be. This is actually this is after sunset, so it doesn't look like it's going to be instability produced. It's
Yeah.
going to be dynamically forced by as this disturbance goes by.
If the timing's perfect, it'll be 2 inches.
Right. I don't know about that. I have to get provisions and everything.
Well, the
else.
ground's too warm.
The ground's too warm.
But it'll be 2 inches at the end.
Right. But a couple things to note, and I guess time is kind of running short. If you go to Professor Martin's QG diagnostics page, you can actually see there is a little, at least from the 6C GFS run, there is this burst of quasi-circuit forcing for vertical motion for ascent right over us during this time period, which is, that's the GFS.
Mhm.
Again, we don't like to look at one forecast. We could change our model. If we could chip to the GFS. Okay. It's kind of a bit more lackluster. It has the precipitation focused toward northwest. But I think certainly you can't rule out the possibility for flakes in the air during the day tomorrow, particularly late afternoon, early evening as this week or a trough goes by. I'm not going to week it's going to be at this point. I think sun is not going to be sufficient for us to get really deep convective showers, but as this upper trough goes by, we might get some modest convection to give us a few snow showers and gusty winds as it goes by. After that, let's go back to just the surface precipitation. After that, again, broad cyclonic circulation over us. It is still relatively moist. Let's go to cloud cover for just a moment. This is sort of integrating all the moisture. You can see this broad canopy of clouds that's going to be over us. That's not going to be helpful. So the weekend is going to be kind of cloudy. This is tomorrow evening. Let's go to 48 hours Sunday morning. We'll go back to the maps. So kind of a cloudy weekend. If you go to precipitation type and rate, the cyclone is struggling to slowly move away, but it's certainly cold enough for frozen precipitation in the northern half of our state over the course of the weekend. Thicknesses begin to moderate, temperatures begin to moderate, probably back into the 40s. Go to 72 hours, so Monday morning. The ridge begins to build and things begin to clear up. So a nicer early start to next week. All the way forward. And we want to anticipate what weather watch will be like a week from now. Let's just do that. I won't go any further. Typically, I don't go much further.
Usually.
Not me. But yeah, it looks like a pretty quiet week coming up after this windy, chilly weekend. We've stayed cool, probably below normal, and relatively quiet. So this time next week, we're probably going to be thinking, it's pretty quiet weather over us.
So what will it be like on Halloween?
All right, you answer. I think I have to go beyond this.
Gets us close.
That looks cold. But let's go to the CFS. And where we go? And at 504. All right, so that's how, it's that Thursday evening.
Warm, breeze off to the west,
Warm,
southwesterly winds, warm convection.
2 meter temperature.
58.
I'm gonna go 45. Right here, right. Sorry. 2 meter temperature.
It's just looking at different runs of that same thing.
Oh, yeah, now we gotta go back to the other one.
Yeah, up, first one. And 55. So, if you want to believe this, and it's been just, what Pete was doing, we can go to any other run, just see how consistent this is. Cooler, Much colder. Yeah, take your pick at this point. That's probably, I bet there's snow on the ground.
Yeah, maybe so.
And in fact, since you've already piqued my interest, go back to that one. This is the last thing, and then actually, this is the
Yeah.
one last thing. You want to get the call? It's the one that was. No. Here we go. It's probably
Those
there.
are
And
consecutive.
let's go to
ones.
the precipitation type and rate. This shows you the precipitation type and rate. I'm gonna see if was there snow cover, snow on the ground following this. Go back to 504. Doesn't look like it.
No.
Nah. 480. 480.
Oh, sorry. You're kind of standing in front of where
Yeah, okay, there's snow, yeah. So there's a bit of a snow event that probably keeps the ground just a little bit colder than normal. But yeah, this is 480 hours. Who wants to believe it? Okay, anyway, so again, weekend, I'm saying largely cloudy, maybe a few snow showers in the afternoon, late afternoon, early evening tomorrow, but less than a foot accumulation, I can guarantee you that. Anyway, thank you all for coming. Again, please watch this and send comments over, if you're coming from a great distance and you want to participate in this, we welcome you to participate. Thank you, John. Thank you, Pete, for setting things up.
Yeah, thank you.
Alumni, if you're here and didn't sign in this morning at coffee, just come on up and sign in. We'd just like to get an idea who all came to this today. So if you could come up real quick. Thank you.
Yeah, I stopped at 48 hours.
That's a stretch.
Okay, 141, we got
Are you good for
1 minute break.
food or?
Sorry.
Hey. Sorry, I'm late. No, that's great. Glad you can make it. You want to just sign this here? I'm sure if we do. There you go. Fantastic. How's everything? Everything is good. Where did all our alumni go? Did they all? And there was like
I don't know.
20 hands over earlier.
I know,
Some in the back by me.
They're all
I think.
hiding.
I didn't look at that. And, do an introduction. Kill the stream here.